Okay, here's our lesson for today. 20.2, we're going to be talking about a different form of quadratic. So we've learned, I guess, two forms so far. We had standard form, which gave us ax squared plus bx plus c. And remember, in standard form, we were able to find the y-intercept and if it opened up or down. We also have vertex form, which we learned was ax minus h squared plus k. Remember, vertex form gives us a few different things. It gives us the vertex, and then we can also find axis of symmetry. And so today's form is going to be called factored form. And factored form is going to be, it's going to look like x minus a, x minus b. And those are a different a and b than we see before. And what factored form is going to give us are roots. So each one of these parentheses is called a factor. And then the roots are going to be inside. And remember, because they're inside, they're going to be opposite. Okay, so the first thing that the first example is just to talk about how to rewrite something from factored form into standard form. So notice that this is not like vertex form because you don't have, like if you look here, there's not a number on the outside, and this is not squared. This is something different. But we still start in the same place. So we're going to start with that multiplication. X squared minus 4x plus 1x minus 4. So that's me distributing. And then, just like we've done before, we're going to bring the 2 down. Just notice there's not a number at the end to bring down. So now this will distribute. That's going to give me 2x squared minus 8x plus 2x minus 8. And remember, the last thing we need to do is combine any like terms, which is going to be here in the middle. So standard form will be y equals 2x squared minus 6x minus 8. If you want to try B on your own, you can. I'm not going to show the work for that one, but I will give you the answer. So if you want to pause and try that one on your own, you're welcome to. And once you work that out, you should get a final answer of y equals 3x squared minus 21x plus 30. All right, so our second example is going to be talking about how to find the zeros from that. So one thing I do want to remind you is that zeros, there are a few different words for zeros. We've got roots, solutions, and x-intercepts all mean the same thing. Sometimes they ask that in different ways, so that's why you need to know all 4 of those words. And remember, what we're talking about is where something, because it's an x-intercept, we're talking about where a parabola is going to cross the x-axis. So, if you remember, in this example, what I just told you is that everything in parentheses is called a factor. So I've got this factor that is x plus 4. And roots come from factors. And think about when we do vertex, anything that's inside the parentheses makes you think opposite. So the factor x plus 4 gives you a root of negative 4, 0. So it's negative 4 because it's opposite, and that is going to go in the first spot because roots are x values. All right, the other factor here is x plus 2. All right, so if we follow that same pattern, that means my root is going to be at negative 2, 0. All right, that's from this second factor. The 2 in the very front, if you just want to make a note for yourself, is just going to be a slope. And I'll kind of show you a little bit more what that means this week. But remember, it just tells you, for the most part, if it's opening up or down. So this parabola opens up, and it crosses through negative 2, negative 4. And we could go through and find the y-intercept. Remember, you could do that by just multiplying the numbers, but that's where we'll leave that for right now. All right, this last little question on this page, though, is important. How many x-intercepts can a quadratic function have? So there's actually 3 different options. Most of them, and because quadratic means x squared, the 2 tells me that I'm always going to have 2 roots or 2 solutions. But they don't always look like what you think. So we could have a quadratic function that crosses 2 different times, and we call that 2 real roots. Or we could have a quadratic that barely touches the x-axis and then turns around. This we call an example, this is called 1 double root. So it's still, we call it a double because it still has 2 roots, it's just that it's the same thing twice. And you'll see what that means coming up this week. And then the last example is when it doesn't touch the x-axis at all, which does happen. We call that 2 imaginary roots. All right, and then this last example is just writing given the information. So they tell me that I have x-intercepts at -3 and 4. And then remember, all these k values, these are just different slopes. So what will they look like in different cases? So if I write a quadratic function, that means I'm going to have y equals, I know the slope is 1 in this first example, so 1. And then think, if my intercept or my root is -3, then that means my factor must have been opposite of that. So my factor is going to be x plus 3. And then my other factor, if my root is +4, is going to be x minus 4. There's no squared here because these are not the same roots. The squared actually would come if you were to multiply this out. So if we write this next one, now it's going to be y equals -3, because that's my new slope. But I still have the same roots, so that's x plus 3, x minus 4. So the only difference with this one is it's still going to cross the x-axis in the same spot, except now my slope is going to be negative, so it's going to open downward. All right, and then last example, y equals new slope of 2, and then same roots, so x plus 3, x minus 4. So the difference between these 3, my first one is going to cross, we said, at -3 and +4. And it'll look something like this. All right, that's the first one, when k is 1. The next one is going to be really steep, and it's going to open downward and cross through those same points. That's when k equals -3. And then my last example is again going to open up, but it's going to be a little bit steeper because it's got a steeper slope there. So that's when k equals 2. So notice that all of those still cross the x-axis in the same points. It's just the slopes that make their graphs look different.